This video is about operations with polynomials. So this video will be jam-packed with some polynomial vocabulary, and then I'll do some examples of adding, subtracting, and multiplying polynomials. So here we go. What is a polynomial? So these are all examples of polynomials in one variable. So poly means many, and nomial means algebraic term. So this polynomial right here, this guy is a monomial because it has one term. So a monomial will look something like this, where we have a constant times a variable that's raised to a non-negative power. So you should write that down, that a monomial is a constant times a variable raised to a non-negative power. We call this constant a coefficient. And we call k, the power that it's raised, as we call that the degree of the monomial. So a polynomial is the sum of many monomials. And when a polynomial is made up of monomials, we call those monomials terms. So that is also an important word. This is tons of vocabulary that's actually very important. So you should write all of these terms down and make sure you have a good understanding of them. So we have monomials, that's one term. We have binomials, that's two terms. And we have trinomials, that's three terms. Now there's more, we can have more than three terms, but for now we'll just keep it like that. We'll just keep our vocabulary to three terms. Polynomials are typically written in standard form. So standard form is when we have decreasing degrees of monomials. Like each of these examples has decreasing degrees. We're starting with 2 in this one, and then down to an invisible 1 degree. Or here we're starting with a 3 degree and then down to an invisible 1 degree. And some of these terms have coefficients, but if it's the first coefficient, we call it the leading coefficient. So let me get rid of all these examples and write a new one. Here's a new example, 3x squared plus 2x plus 5. So this is clearly a trinomial because it has three terms. 3 is the leading coefficient because it's the coefficient of the largest term. And what I mean by that is that it has the largest degree. So we say that this has a degree of 2 because it's the highest degree. Now 5 doesn't have a variable, and we say that 5 is the constant of the polynomial. But not every polynomial needs to have a constant. So that's some polynomial vocabulary. Again, it's really important that you are able to use these words and you're comfortable with them. So make sure you can speak fluently, I guess, with these mathematical terms. So we can add and subtract polynomials, and it's just like combining like terms. So say we had a problem like this. We have a trinomial plus a trinomial, and we're just going to add like terms, and what I mean by like term is they have the same variable raised to the same exponent. So looking at the highest degree term, this guy, x to the third, does not have any friends. There's nothing else that has x to the third. But this one, negative 4x squared, has one over here with 5x squared. And then 2x is all by itself, but then there is a constant in both trinomials. So we just want to combine like terms, And so we'd get something like this. 3x to the third, and then we have 5x squared minus 4x. So 5 minus 4 is 1. We'd have x squared. 2x is all by itself, and then we have 3 plus 7, which is 10. So let me show you another example, and this kind of problem often gets students. So before that previous example, I added, but when you subtract, you have to be really careful to first distribute this negative sign. So make sure you distribute this negative sign before you combine like terms. So at this point in the video, I want you to pause, do this problem on your own, and when you're done, press play and check your answer with mine. Okay, welcome back. So I got 3x to the third minus x squared minus 7x plus 10, and I made sure to distribute the negative sign, and then also combine like terms, and then in the end put my answer in standard form. So that means it's decreasing degrees. Alright, so that's all fine and dandy. We added and subtracted polynomials. We can also multiply polynomials. So we can have a monomial times a monomial, we can have a monomial times a binomial times a binomial, and so on. There's so many different combinations that we can have. So let's start by looking at this example. And so with this problem, you would just use the distributive property and make sure that you distribute 5x squared to everything inside the parentheses. So I want you to do that on your own. Pause the video, work on this problem, make sure it's in standard form, and then press play when you're done. Okay, welcome back. Your answer should be what I have right here. So I know that you got a lot of practice in your previous math classes doing a binomial times a binomial. And when we do a binomial times a binomial, often we say, or your math teacher says, you should FOIL it. So that stands for first, outside, inside, last. So I'm guessing you're probably pretty good at this. Not too much need to review this, but we go first, outside, inside, last, which would get us 6x squared minus 15x plus 2x minus 5, which in the end we get this, 6x squared minus 13x minus 5. So you've probably seen that a lot, but have you seen something like this? So this is a trinomial times a trinomial. When you approach a problem like this is what you're supposed to do. You got to make sure that every term gets multiplied by each other. So we would multiply or distribute 2x squared to everything, and then we would distribute negative 3x to everything. And then lastly, I'll use a different color, yellow, we'll distribute 1 to everything. So I want you to try that. Multiply these two trinomials together. Press play when you're done. Okay, welcome back. I almost made a mistake, but I think I got it. Your answer should be 2x to the fourth minus 13x to the third plus 30x squared minus 26x plus 7. The last thing I want to talk to you in this video is just kind of recognizing some special patterns, which hopefully you covered in your algebra class, and might have seen it in your previous class if you took geometry. But there's some special patterns. Sometimes we have a binomial squared, so sometimes we have a binomial squared, and sometimes we have the difference, a binomial, but we change the sign. And so there's special patterns here. And earlier, when you were in your previous class, you might not have emphasized the memorization of these patterns, but it's really will save you time if you memorize these patterns. So you could FOIL them. You could do a plus b times a plus b. If you FOIL it, you'd get a squared plus 2ab plus b squared. Same thing with a minus b. You could FOIL it, but if you can recognize that the pattern is a squared minus 2ab plus b squared, you're going to be ahead of the game there. And then if you recognize this pattern, that it's just a squared minus b squared, again, you're in good hands. So I think that's it for this video. Have a great one, and let me know if you have any questions. Thanks.